Hey guys, welcome to episode 4. So today we are going to make the character move in the direction that we're actually looking with our camera.
Make sure to check out the companion page. Patreon always helps us out. I wonder if that's it. Remember to join our Discord, but let's get into it. So where we left off was getting our camera to move, but our player kind of moves like a tank right now. He doesn't turn, and the direction we want to go doesn't match up to where the camera is turning.
I think the first thing we should do is just get our character to rotate in the direction that they're moving. So to do that, we'll go into our code and we're going to be in the player GD script, just like you are. I think this is a good opportunity to just show writing something in its own function. That way we can implement it once and then reuse it in different spots where we need to later on. And it'll just also make our code read a little better in terms of like what we're trying to do.
Because right now we've basically just been working in like function, physics process and on ready, which are kind of the ones that you do use in most things. But now we're going to be making our own function.
Mm-hmm.
Okay, cool.
At the bottom of this file, we'll just do func to start a function declaration. And then let's name our function turn2.
We're declaring a function. We haven't said what it's going to do yet. We're just naming it right now. And it's mad at us because it wants us to cap it off, but we'll do that in a second.
Well, I mean, we'll do that now.
Oh, really? Okay. Okay, great.
We got to put the parentheses. That's where our parameters or arguments will go in a second here. This function is not actually going to return anything, which means we need which type of return?
Void, baby.
That's right.
I know, which means we can look at this. I'm doing this custom, me typing an arrow. Holy cow. Using void and knowing what it generally means.
Which is nothing.
Yeah. And again, that's being a type safe boy.
That's right.
Okay, and then depending on what's going to be underneath, we're probably going to put something in there eventually.
We are, yeah. Why don't we just go ahead and put pass in there for a second, and let's kind of talk through what we're trying to accomplish here.
The goal for the turn2 function is that we want to take our direction variable, which you can kind of think of like an arrow pointing somewhere in 3D space. And then we want to take our character and rotate them on their y-axis, their yaw, to look in the direction that arrow is pointing.
And real quick, since var input dir and direction are tabbed underneath function physics process, doesn't that mean they're scoped to just be these variables are only used inside of this function? They can't be used in our turn2 function?
That's exactly right. Okay. And so that's why we're going to want to take in direction as an argument for turn2 or as a parameter of turn2.
Right here? And this is taking it from the other function.
Well, we're going to have the other function give us direction.
Okay.
And then we can do something with it. We need our colon for our type safety.
Yeah, let me guess.
Yes.
Come on. I literally could program Metal Gear Solid 6.
Now we need to actually incorporate it into our physics process. Because right now, the function's not going to do anything until it's called. So we're going to have our physics process function call it and hand it direction. And this can happen pretty much anytime after we've declared the direction variable.
Okay. It's weird that like all this stuff is in your head.
So what we can do is we'll just go right after line 27 and we're going to do a function call to our turn2 function we just made.
Okay. Inside, like tabbed into, can it be just right on move and slide?
Yep.
See, this is, again, where a function call is this, I believe.
Mm-hmm.
This is where it gets weird. Hang on real quick. Too few arguments for turn2. At least one, but receive 0. And that's because it's expecting a vector 3. How can you say a vector? Oh, could I do a vector 3 here? And it's okay. Built-in type cannot be used as a name on its own. 0. Happy now? Type has to be in a vector 3. Okay, 0, 0, 0. How about that? No, too many arguments for 2. Receive 3 needs 1. Okay, back to 1. No, it needs to be 3. Okay, 0.00, 3. No, it needs to be a float. Okay, 1.1. Value float is vector 3. 1.1, 1.1, 1.1. Saved. Crashed. What the frick, man? So, I thought I was being so high Q with that first one of just being like freaking vector 3, obviously.
You were so close on both of these things of what would pass here. If you want to make a vector 3, right now you just have the type. But to construct a vector 3, you need to call it. A vector 3 has a constructor, which is like a fancy hidden function on it that makes the vector 3. So if you call vector 3, yeah, you figured out the actual solution.
Yes. Okay, real quick, sorry, by the way, that was a lot of me thinking and not speaking it out loud. Where I was confused first was it's weird that like code, it goes down, then it jumps back. like a lot. Our goal is to get direction to be able to be used in the function of turn 2 because it's stuck in physics process because it's in the scope of physics process. It can only be used there. So the way we do that is to go into this function and be like, I'll need direction in the future down lower in the script. So right now, the function that we're making, even though it's outside of physics process, it's going to be working inside of physics process.
Correct.
We just define it outside of it. I made a call for turn 2. I think this is where I got hairy. It says that I need, I'm expected at least 1, but receive 0. There's too few arguments for turn 2. So I have to, like, as a noob, I'm like, so it's expecting a number? Like, why am I, like, can you explain what I'm trying to get in there?
So what you need is a vector 3. So
I guess, I don't know what would tell me that this.
Yeah, that's what's telling us we expect a vector 3. So let's just do a quick test to make sure we are getting direction as expected. And we're going to do that by going on to line 31. Yep. And we'll just type print. So we'll do our print function call. And we can just hand it direction. Or you can type a message, comma, direction. Okay. And you can remove the pass at this point.
Okay.
Yeah.
We can play.
Mm-hmm.
And I imagine it's only going to print when it moves. Okay. It's always printing the stuff because it's in physics process because it's doing it every tick. Okay. And now it is giving us the direction of the keys I'm pressing, not the location of my player. So the direction, who would have thought, of the keys I'm pressing.
Yeah.
Okay.
Cool. Now we can start writing our actual code to rotate the character in the direction that we're trying to move.
Mm-hmm.
Ultimately, what we have to drive here is our player character's yaw. So that's the name of one of the rotations. That's when you spin the character around on their vertical axis as if they had a pin going down through their head.
Yep.
So let's first figure out what that's going to be. Why don't we go to the 3D scene and try the different rotation axes and see which one we want to spin?
Do we want to spin the player or the mesh?
So that's a great question. There's a lot of things involved with answering that question, but let's actually rotate the player and let's discover an issue that we're going to have and work through it.
So it looks like the Y is the yaw.
Yep. And you'll notice that the camera is now rotating with the player. So now we'd have the camera rotating around the player and then also rotating with the player. But if we want to solve this, there's 2 things we have to do. First thing we'll do is we'll go to our spring arm 3D, which is our camera rig node. And there's going to be an option in your transform called top level.
This guy. If true, checked on, the node will not inherit its transformations from its parent. No transformations are only in the global space. So it almost would like separate itself from the player rotating.
Correct.
So if I turn that on and go to player and I try to rotate, whoa, all sorts of rhombuses or rhombi are happening.
Yeah. So now if we were to play the game, go ahead and try playing the game real quick, in fact.
Okay. Yes. This feels really weird. Kind of cool, but weird. Oh, and my spring arm is still kicking in. On the player this time, though.
If we want to not only be able to push our camera away with the spring arm, but have it actually follow our player again while ignoring rotations, we basically just have to write a little bit of code that says, hey, follow the player node every frame, and that's it. So I think the best place to put that... I'm sorry, it's just so funny seeing him move. So I think the most natural place to put that code is going to be in the camera rig script.
Camera rig script. So let's go to the spring arm script.
Mm-hmm. So the player character is only updating every physics frame, meaning we don't need to track it every frame, every render frame. We just need to track it as much as the player is moving.
Okay.
So we're going to add a func physics process to our camera rig.
Okay, I was like, are you about to say that we're going to put this in process? I'm like, wouldn't we need a physics process?
Well, you thought right. And we're going to need a reference to our player, which is currently the parent node, because we looked at the node tree and we went up the tree. Player is the parent of the current node.
So the way I would do that is by cash money sign player.
Well, that would be if it was a child of the spring arm.
I mean, yeah, couldn't I just do like player dot?
No, because there's no player variable here. We want to get the parent node of the current node we're in. So by just saying that, what might you try typing to see what pops up in IntelliSense?
Parent. Get parent?
Get parent is what we want.
Really?
Yeah. So we could say get parent dot position whatever, but functions have a cost to them. So when you call a function, it has to go jump to other part of code, do stuff, and then come back. Mm-hmm. But that doesn't mean we avoid functions altogether. Functions are still really important.
Does this get access to players' scripts functions?
Yes.
Okay, so this is like kind of our first step into like scripts being able to communicate to each other and into each other.
Yeah.
This confused me so much when I was getting into code at first because I was like, wait, do signals do this, or what is all this thing? Like, how do these things talk to each other? This might be it. We might be on.
We're getting into the magic sauce here.
Yeah.
We don't want to have to do this work every single physics frame because that's going to happen a lot.
Right.
It would be nice if we just got a reference to our player once because it shouldn't change. I mean, if the player node's deleted, then spring arm's going to be deleted. What we can do is we can go to the top of our file, and then just like we got a reference to our camera on line 3, we can get a reference to our player.
Okay, so var player, something like node 3D, I'll let that slide for now, equals, I could do get parent here.
Yep.
Get underscore parent.
Yeah.
Parent. Boom. Node 3D was right though?
Node 3D is fine, yeah.
Fine or correct?
It's correct. I mean, because think about it, like what we care about on the parent
Just tell me
isn't
I'm right.
that it's necessarily yeah. What we care about isn't that it's a player or that it's a character body 3D. We just want to get its position, which we haven't really outlined why.
And the position is inside the transform of the node 3D.
Correct.
So you're saying that node 3 is fine. If we wanted to get more technical or more properties to work with, we could go further in that inheritance.
Correct. You could say character body 3D, and that would get you more specific. So now we have player at the top, which is our parent, which is going to be the player node.
Oh, so we can just do player instead.
Bingo. So what we need off the player is the player's position.
Dot.
So if we do player dot position, yep, you got it. And now we need to change the camera rig's position to be that position. We want to not follow the player's rotation from the camera, but we want to match the player's position from the camera.
Okay.
How do you think we're going to do that?
Camera's position to the player's position equals camera dot position.
Why don't you go ahead and try it? Let's see what happens.
I have a feeling it's going to be wrong. Okay, crashed. Invalid assignment of property or key position with value of type vector3 on a base object of type null instance. Of course.
The problem here is the null instance part. Get parent, when we call it at the top in the variable declaration, technically when the camera rig node is created or when the script is initialized and everything inside of Godot, it's not really a part of the tree yet. It's only a part of the tree after ready is called or when ready is called. So in order for get parent to return the node that is the parent of it in the tree, we first have to make sure it's in the tree. And this is where at on ready is helpful because that's like putting it in the ready function, which is when the camera rig script and node is actually a part of the tree. So this is where we would put the at on ready in front of var player is node 3D get parent.
Okay.
Now our code on line 34 is going to technically work. It's going to function. Whether or not it functions correctly, now we can test. So go ahead and play. Yeah.
Whoa. Am I moving? Okay. Now I can't move my guy.
So I don't think we're quite there yet.
Okay. Basically, I'm setting the player position to where the camera is and nothing else. So now I can't move. Got it.
Yeah.
Okay. What was the original question that you wanted to ask me here?
If we don't have anything here, the player can move away from the camera. And the camera's just kind of spinning in place. We want to make the camera rig follow wherever the player's position is, but not the rotation. That's why we turned on the top level flag.
Wouldn't I do this then?
You're getting way closer. Yes.
Okay. You tricked me with setting it up the opposite way. You fed me to a pit of snakes. Camera.position equals player.position. Okay, let me test this and see where it's going wrong as a true game designer. Okay, but now I'm like inside the player, and I think I'm moving around it like this because I'm in the sphere of the thing.
I think there's a couple things happening here all at once.
Yeah.
It's making some issues.
Yeah, and I almost want to say like player.position and also remember you're a spring arm, so don't be so close. Dot equals player position.
Well, here's a question for you. Is the camera variable the spring arm?
No, it's just the camera 3D. So we want to get the entire spring arm. Okay. Tell me if I'm wrong. Do I need to set a variable for the entire camera rig?
Nope. You are in the camera rig. The script is the camera
So
rig.
I want to almost be like, get myself. Like, get...
I liked your use of the word self. Start with that.
Self dot position equals player position? No way. Where were you self ever?
It's a good thing to kind of call out. There are cases where you'd want to use self, like if you wanted to pass yourself to something else. But in the case of GD script, we don't actually need to use self in this case.
So we don't do that?
You don't have to use self. You can omit it.
Oh, I can just say position equals player position.
Oh.
Yeah, because we're talking about, okay. Just to be clear here. When we call position in general, it is talking about the thing that we are currently in, which is spring arm script, which is the whole rig, the whole camera rig. Did we rename this ever to like camera rig? We didn't.
No, you can rename it now if you want.
Yeah, I'm going to rename it to camera rig real quick. And I'm going to do Pascal case. Boom. We are like more on the floor or something?
Yep. This is it's kind of similar to the spring arm problem, where the spring arm is every frame setting the camera where it should be based on the spring arm's length and all that.
Yeah.
We're now setting our camera rig to match the player position. If you remember, the player's like root position is their feet.
Yeah.
So there's a way we can solve this.
So why are we low? We need to get high. Player dot position dot y equals position dot y.
So you're I can see the gears turning, and they are starting to turn the right
They're
direction.
always wrong. My gears are useless. I just want to see what happens if this happens. Like, just if you weren't here.
Sure.
Nothing. It does nothing.
Tell me why nothing happened. Look at the order of operations here.
Okay, look at the order of operations. Position equals player position.
For the type of game we're playing, we want to match the cameras up and down to wherever the player is, right? If you jump, we want the camera to follow you when you jump. If you fall, we want it to follow you when you fall.
Yeah.
We can't just say, hey, ignore your y-axis. We can't just say the camera is not going to move up and down, because that's not true. What we need to do is we need to find the difference from the player's feet to where the camera should be, and then add that back in here.
Okay.
What that would look like, you can go ahead and delete line 35. We're going to add two vector 3s together, which just means that x and x get added together, y and y get added together, and then z and z get added together, and then that will be returned. Try adding just a vector 3. Like, we're going to make a new vector 3 here instead of position. And then think about, like, you know, how far up or down you need to move.
How far up or down I need to move? 1.365. Okay.
So keep in mind your 3 arguments here that you can pass to this. Yep. There we go. So try playing that.
This is gonna work. Yeah, we're back to we're 90 steps ahead and back to step 1. We're where we were earlier.
Remember how we, on line 11, stored the difference of the camera in order to set the spring length to that? We can kind of do a similar thing here, right? Where we could store like the height offset in a custom property of where we are starting from. So your instinct of position.y was correct. It's just in the wrong spot, because by the time we're in physics process, it's too late to store that.
Okay, so almost like I would do var camera rig height equals position dot y, and I would have to do the height of that, which would be a vector 3.
If it's just one component, it's going to be a float.
Okay, it's one number in the vector 3. Gotcha.
Yeah.
And I might even want to put this at the top, because that usually just happens just for cleanliness. And then I can be like position equals player dot position vector 3 0 0 unaffected, and then I can do camera rig. And this is where I understand the concept of storing a number, unless I'm completely wrong. That might be a problem. Camera rig height, bam.
Okay, you are almost 100% perfect. The only thing wrong here is where camera rig height is. Because right now it's inside the function. So when the function starts up, it's going to create that variable. And then when the function's done, it throws it away. That's my guy.
Do I have to put on ready? Sorry, do I have to put on ready?
Maybe. Why don't you try and just see what happens? And
Yeah.
We'll figure it out after.
Everything sees to be okay.
That's correct. We've solved this problem. We now have the
Which, by the
camera
way, has
not-
changed absolutely nothing.
But it's important, because otherwise, if we got to the next step of rotating the character, we'd be making ourselves sick.
Yeah. Okay.
Now we can head back to our player script.
Okay, Nicholas, I'll play your little game. Real quick, me and Nick got into a long rabbit hole about one thing. Make sure your code is still the same. If anything, we changed line 30 and 31. Just make sure it's the same. And same with your camera rig script.
So now we need to start figuring out how to rotate our player character. And we've rotated our camera and camera rig stuff before, right?
It's just so funny because it's just like we've been doing like it wasn't that originally the question an hour ago. Oh man.
So
if you guys only knew how long this is taking to record. It's hilarious, dude.
So we know that the y-axis is the yaw of the player. That's what we have to turn, right?
Yep.
And we want it to turn relative to the direction the player is moving, which we have as direction. And I'm going to just kind of wave my hand to an explanation of what the math is here.
Atan2, which stands for the arctangent of two arguments, is a math function that calculates the angle of a vector from the origin to a point. If that doesn't make sense, that's okay. We're pretty much going to write this code once and then never touch it again. By giving the function the x and z components of our direction vector, we can find the angle of that vector in relation to the positive x-axis. We also need to make sure we negate both arguments because Godot uses a different coordinate system than the one we typically think of in math.
Great, you're back.
And we're back.
Right, var instead of pass. We're going to put this into a variable, and you don't have to. We just are, so it's clear what's happening. We're going to say yaw. This is going to be the change of yaw we're going to do, and then we're going to do the colon equal because we're declaring it with an initial value, and we're going to look for atan2. Yep.
That's one of those purple things. I haven't seen that since print or move toward.
Move toward. Yeah, it's a global scope function.
Maybe it's not that special.
And then what we're going to hand it, it's going to look kind of weird. We need to basically take our direction, our x and y of our direction, and negate it. So we're going to say minus sign, direction dot x, and then comma, and negative direction dot z.
Okay.
And note, by the way, that it's expecting this all in radians.
Okay. So we're not
when we
switching
apply
it to
this-
degrees.
Right. So now what we can do is we can say after this line, rotation dot y, again, not rotation degrees, just rotation.
Of the
And we're
object
gonna
we're in, which is player.
Mm-hmm. And what are we assigning to rotation?
Yeah.
Boom. Okay, let's go ahead and try playing that.
Whoa. It's
Okay.
okay. Were you expecting that?
Kinda.
Basically, as soon as I move left, right, or down, anything besides forward, it just turns into like.
One problem is right now our character is moving with tank controls. And so the moment we rotate, now all of a sudden the left and right key is causing you to rotate right, and then you're just moving one frame worth and then rotating again, and then moving one frame worth and rotating again. So I think what we should do real quick is we should get our camera relative movement in place. That way we're not moving based on the character's rotation, which means that we can't ever move from one spot.
Okay.
Unless you go forward, maybe. But-
Forward, yeah, forward works.
So shockingly, for the most part, I think getting camera relative movement is actually going to be the easiest thing we've done so far. What we need is we need to get the camera's transform information, and we're going to use something on it called a basis. Now, this is a type of matrix, and we're not going to go super deep into matrix math because I'm not probably good enough to teach it well.
Okay.
Okay, so what we're going to do is we need to now get a reference to our camera from our player.
Okay.
Why don't you go to the top here and get a property going, because that's usually where we put our references.
Okay, so it is a child, so I can get camera rig, camera 3D. No 3D, I think. Default value setting which won't return nodes in the scene tree before ready is called. Okay. On ready. At on ready. Is that right?
Boom. You got it.
I didn't even know about the slashes yet. That just IntelliSense saved my booty.
So on line 20, notice that we have vector 3 kind of towards the middle of it, where we construct a vector 3 of our input. And then we're going to normalize that result. But there's that part at the beginning of this expression that we're assigning to direction. Transform.basis.
Yep.
So right now it's using the current transform of the player. But we want to actually use the transform of the camera.
Would I be writing this in physics process here now?
You'd be writing on the same line. You're going to change that line to change what the basis is.
So it'd be camera dot. Yeah.
Now try playing your game. Let's see what happens.
Okay. Whoa. Look at that. I like how he wants to be backwards at first. I don't know what that is about. We are moving in all directions like a Game Boy Advance character with no smoothness whatsoever. However, if I use a controller, look at that. With a controller, it's smooth, but it's backwards. Up is down, down is up. left is right, right is left. And I think I know why it's doing this. On the controller, whatever we did, it's backwards. On the mouse and keyboard, it is correct.
The problem we're having right now is camera.transform is the relative transform to its parent. But what we actually want is the global transform.
Gotcha.
In player.gd, instead of camera.transform.basis, what we should say here is camera.global transform. Basis. We want to get the global transform of the camera.
Global transform?
It's an underscore. And there are also some helper functions or helper properties inside of Godot. Instead of global transform.basis, we could just say global basis. So they have kind of an overload that means the same thing. So let's try that and see if that works any better.
If this works, I will be so confused on why. All right, mouse is good. Gamepad is good. Feels like a video game.
So the reason is that if we use the relative transform, it's relative to the camera rig, which makes a bunch of our math really incorrect.
Okay.
If you were to aim the camera down at the floor and then pull back on the joystick, I just want to check if something happens or not.
I slow down.
So this is a problem.
Which we can solve. Yes, it's the next day. My hair looks different. We took a break.
So does mine. All right, so to solve this, what's happening is that when we look into the ground and we hit forward, we're moving relative to the camera. So we're trying to move forward from the camera's perspective.
So almost like our eyes behind the camera, behind the guy, are like aiming down or moving relative to the camera.
Yes.
Okay.
Exactly. So there's a couple things we're going to need to do, and we're going to do this in steps and try a couple things. The first thing we're going to do is just remove that dot normalize. So right now, all direction represents is we took our input and we remapped it as it is to the camera's direction. So if you were to do up and down on the left joystick, you're now moving the camera forward and backwards, even if it was just directly into the ground.
Okay.
So we could do this next part and make a new variable if we wanted. Or since direction's already a vector 3 and we just want to kind of change it a little bit more before we're done, we'll just go on to the next line. And we're just going to say direction equals, because we're going to assign a new value to direction.
var direction equals, if direction equals.
I know.
So how many more freaking times are we going to define this thing?
Well, it's only been defined once. We're just using it in a bunch of
we use it
spots.
Everywhere. Look at how many other times it's used.
Yeah. So we're going to do vector 3. So this is constructing a brand new vector, okay? And we're going to use our previous direction to make this new vector 3. And then what we're going to do is we're going to go inside that. Yep. We're going to use direction.x as the x of the new vector 3, and then a comma 0. And then we're going to do
so sucking the vertical out of this.
Yes, there's now we're not accounting for any of the vertical.
Okay.
Then we'll do direction.z, and we're going to normalize the result of this.
Now, real quick, I think something's kind of adding up in my head is the reason why we're doing, like, it feels like we're defining direction again and again is also because with more properties that we're adding, we're redefining what direction is later on.
We're just replacing it.
We keep redefining direction because it's like, we're adding more and more things to direction to get it to behave appropriately. For instance, we're sucking here, sucking the Y out of it.
Yeah. And then we're taking the result of that and normalizing it and then storing that back in as direction because we're modifying what direction is.
Yep. Which is hilarious because we like right above here defined it and we're like, let me change my mind actually.
Yeah. Well, it's because you got to think about how like the expressions on the right hand side of the declaration, it's like, okay, we do that expression, we put it in the box. Then we're going to do some more expressions, more work involving what we had in the box before. And we're going to take the result of that and then put that in the box. Try playing that. Let's just see how that feels and see what goes wrong.
Oh, feels good. Feels good. I feel like you're about to be like, well, do this. And then my guy explodes.
Am I so predictable? Yes. Yeah. Try using the controller.
I think the only issue is, I can't accelerate. I literally am always at max speed.
Yeah. If you wanted to like walk,
yeah, you're
always going max speed. Thankfully, this is going to be an easy change.
Yeah. That's what he said the last 70 steps.
We're going to take the length of magnitude of our input direction. If you're pressing 1 on the stick to the left, then the length is going to be 1. If you're pressing diagonal, so the X value is 1 and the Y value is 1, then it's going to be 2, but then normalize will come down
Bring it
to
down
1.
to 1. Yep.
But if you're going 0.5 only in one direction, then you're only going 0.5. So if you're underneath that like normalized value, then what we can do is we can take our normalized value of 1, so on line 21, And we can scale it down to account for the total length that we had on our left stick, even if it's less than the value of 1. So we're going to times, and we're going to do input dir dot length.
With a function call?
Mm-hmm.
Okay.
The dot length function is going to go add up the absolute values or the non-negative values of the vector, and then that's our total length.
Okay. This brings it down to 1, this part, up to that point, and then it's saying...
It brings it down and up to 1. Because if the value was less than 1, like if you had 1
and then this is multiplying it back to what it is below 1.
Correct.
And I literally flunked math for so long, man, over and over. My parents, the amount of disappointment that I am literally hurtling over is just, it would make my dad cry if he saw this.
The amount of disappointment?
Yeah, but he's not going to watch this because these videos are too long for him. Okay, wow. We can creep and crawl. And then, dude, like, animations are going to be like, oh, if my velocity is under this speed, be in crawl, then blend to not crawl, but walk. Then next thing is running, sprinting, and then next is freedom.
Yeah.
And then flying. Sick.
I think our next thing is to just quickly fix the turn 2 and get out of code for a minute.
Yeah, thank God. I mean, yeah, great. Totally love this part.
To fix the rotation thing, we need to go back to turn 2.
Down here?
Mm-hmm. And we're in turn 2. The problem right now is we're always snapping backward. Let me start with this. Why do you think in turn 2, every single frame, your guy spins back around?
A tan. Does it have to do with a tan? Because I still don't really know what that means.
All we need to know about that
Both
is
of these are negative
direction.
to start.
Well, that's fine.
Okay.
The calculation's correct.
Do I just need to, like, do that?
No. It's more of a logic problem. All we have to know about the A-tan2 thing is that's taking our direction and it's converting it into a rotation. And then we're setting our player's yaw rotation to that rotation.
Yep, of just the Y.
And we're setting that every frame. Yeah, on just the Y.
Oh. Is it basically like yaw? There should almost be like an additive thing instead of a setting a thing?
No, I was a little worried that your brain was going to go there because I used that previously.
Because I know how stupid it is.
No. No. It's why don't you go ahead and play for a second and then just tell me when it happens.
I think it's like every time I let go of input.
Mm-hmm.
Yeah. Every time I let go of my left stick input. And it's always facing that direction. Yeah, that global direction. Maybe not global. Maybe that doesn't matter.
It does matter. Because that direction it's facing at the end is 0. So you're always setting the yaw to 0 when your left stick is not doing anything. And your left stick is what?
Direction.
Yeah. When direction is 0, meaning you've let go of the stick, then what happens is on line 34, we're setting our yaw of our player back to 0. Because there's no more input. So all we need to do is say, hey, if direction is 0, or like we don't have a direction, don't do anything.
Okay.
And I think the easiest way to do this, I mean, there's a bunch of ways we could do this, but what we'll do is go and delete that line. You're actually very close. All we need to do is add a conditional then around this calculation. So let's just go up to a new line between 32 and 33. And here we'll do an if, and we'll say direction, and then just do a colon. Now put line 34 and 35 in the body of our conditional. So that's just tabbing it in. If we use a vector 3, like a Boolean, basically, in this case. So we're saying, hey, if direction, well, it's not that direction's true. It's that if direction is not 0, because direction's a vector 3.
This is already incorporating the 0 thing?
Yeah.
Ugh, that's like a brain leap for me.
So if you want to see it more spelled out, you could do, if direction dot length, and then do is greater than, and then 0. So only if we're not getting 0, then rotate the player towards the direction.
So this would work the same as this.
Mm-hmm.
I don't get why.
It's just magic.
There we go. That's all I needed. No, I needed to hear that.
Yep.
Well played, Glenn.
But if you play on keyboard right now, what happens is you rotate around.
Kind of snaps to each direction like an old stop motion.
So do you want to just rotate this guy around more smoothly?
Yeah.
Okay. So to do that, we just need to add one line of code, and we're going to add this in between lines 34 and 35. This is why I actually put these on 2 separate lines. So what we're going to do is we're going to take our yaw and we're going to assign something else to it. And we're going to use a function called lerp angle. So lerp, linear interpolation, angle, because if you're doing it on angles, it's a little bit different than if you're doing it just on standard numbers.
Real quick, lerp has always basically meant to me when I've used it that it's like a smooth transition tool. Linear interpolation sounds so crazy, like, well, of course, a linear interpolation mixed with the quantum physics of nuclear implosion. It's just like, what? It just mainly just means it smooths things out. Not smooth things out, just it's used to smooth things.
It gets used a lot for that, yes.
Yeah.
What's happening is you just have a point A and a point B, and then you feed in a value that's like, okay, go from here to here by this much, which is, going to be a value of 0 to 1. Okay, basically so 0 to 100%.
You 0 to 1, and then weight. I don't know what that means.
So weight is that percentage value of how much you want to go.
So could that be like really fast or really slow?
Yeah. The weight decides how much between these two values we're going to rotate towards.
Okay. If it was 1, would it be instant?
Yes.
Okay. And if it was 0.1, would it be really slow?
Yes. And it's really slow because we're doing this every frame. Now, the thing is, I'm going to go ahead and let you play this.
I think he's turning.
No, he's kind of sticking to one spot because the values you gave it,
you're right,
it's interpolating between are 0 and 1. So it's going literally to 0.1 in radians, and it's setting that every frame. So the from and the to values, that's the A and B, the 2 points I talked about. We got to feed something else into those. Those aren't 0 and 1.
They aren't 0 and 1.
Correct.
Okay.
What we're going to do is we're going to take our current rotation. So you're going to do rotation.y, comma, and then the value we're trying to get to is our yaw. Okay, and now we got to say how much we're going to try to get to that basically every physics frame, right? And for this, let's just use like 0.25. And think about it this way too. This is also an accumulation because every frame rotation.y is going to be moving closer and closer towards our desired rotation. And that's why it feels smooth.
That feels so damn smooth. Sheesh. All right, first of all, if I did 1...
Before you touch anything, what do you think is going to happen?
It's going to instantly go to the thing. So it's going to match it.
Got it.
Yeah. Okay, there's that. All right. 0.2501. I want to make it really slow to see, like, does it forever catch up? And it's just kind of always moving. Okay, that's funny. That's almost like... So could you make a tank game like this?
Mm-hmm.
Because it's like forever trying to catch up.
Yeah, but it's only going to do that while you have direction applied, right? Because we're doing that check to say, hey, if you're not applying any movement direction, then don't do any rotation. So you'd have to keep holding forward, and then it's going to slowly move that direction or rotate towards that direction until you stop.
Yeah, it's interesting. So the direction's like connected. The movement direction is connected to the thing. So it's catching up when I move. Not even catching up. It's just,
just moving towards it. We got through that. We
Boom.
did. We made a player character that now moves like Link in Breath of the Wild or Guy in Elden Ring or whatever.
Guy in Elden Ring. Elden Ring guy.
In Elden Ring. Yeah.
The famished or tarnished. There it is.
Soul Boy.
Yeah.